Hello, my dear students and the rest of the learners. Welcome to part 6 of a 22-part series of tutorials in Managed Database System using Microsoft Access and SQL. In this presentation, we are going to be looking on the implementation of database design through data normalization. My name is Memeji M, or you can simply call me Emily Swap. Let's commence by asking ourselves, what is database design implementation? Database implementation design refers to the process of creating the physical database structure based on the logical model, including the setup of tables, the fields, keys, relationships, constraints, and other database objects. It also includes defining data types, the storage structures, the indexes, and sometimes security rules. Therefore, to implement database design, a number of logical steps are involved, which include commencing the process by gathering all the required data and combining it into a single flat file, after which you then proceed to normalize your large and organized data into lean, elegant, and tidy relational tables that are ready for creation using a database management software such as Microsoft Access and others. And therefore, once you are done with the normalization process, you proceed to define what we call the primary keys, the foreign keys for your normalized tables, and to determine the relevant relationships amongst the tables by making what we call an entity relationship diagram. After that, you proceed to create the tables using your database management software by designing each table and setting its properties, setting the relationships as per the ERD, and capturing your raw data into the database. When designing the tables using database management software, you set the primary keys for each table. As we have already said, you set the foreign keys in order to maintain the financial integrity between related tables. Or in other words, you ensure that you maintain the financial integrity between those tables that you have created and established relationships. You also establish the necessary field constraints by adding validation rules, default values, and input masks to ensure data accuracy. Enforcing referential integrity so that the relationships remain consistent is also key. For example, you cannot enroll a student who has not been enrolled or registered or whose data has not been keyed in a student's table. Once the database tables are ready and linked together, you then proceed to enhance the user interface for them by creating database forms, executing queries, and producing reports for user application in decision-making. Therefore, after designing your normalized tables, such as students, programs, courses, enrollments, departments, and others, you move on to the implementation stage by creating these tables in Microsoft Access, assigning field properties for them per each field. For example, date and time for date of birth field, the text for names, etc. After that, you proceed and you set the primary and foreign keys for each table, and you build your forms for data entry and reports for academic performance summaries. So, my dear students and the rest of the learners, it is important for you to note that the foundation for creating an effective and efficient database that can enable an organization achieve her goals or objectives, as well as improve the efficiency and the effectiveness of data management, as well as enabling the organization make effective decisions that are grounded on empirical data, as derived from the established database management system, is by undertaking an initial intensive data normalization process. So, what is database normalization? Database normalization simply entails data normalization. And what is data normalization? Data normalization is the process of organizing your data in a database to reduce redundancy and improve data integrity. It involves structuring your data into tables and defining relationships according to normalization rules, such as the first normal format, second normal format, and third normal format. The raw data from physical files in an organization that wants to computerize its data is organized to reduce redundancy, improve data integrity, and establish logical structures so as to improve on data management operations and lead to effective decision making. Therefore, data normalization entails the process of structuring or splitting a big, messy data that is composed of repetitions from multiple files into smaller, related tables that are linked through keys, which we call the primary and foreign keys, therefore making sure that that data is stored in an efficient form in order to inform database system as well as the database users on access of that information that is in a simple format, which can be easily used, maintained, updated, or queried without causing anomalies. And therefore, in a nutshell, when we speak about data normalization, we are talking about keeping each piece of data clean in a single logical place, or what we call a table, and with clearly established relationships, thus helping eliminate data redundancy, improve data integrity and consistency, simplify data maintenance, enhance query performance for specific tasks, enhance data clarity, support scalability and flexibility, and reduce data anomalies. So in other words, my dear students and the rest of the learners, data normalization is key for any database creation because it has a number of advantages. As we can see, data normalization or a good normalized database has number of advantages, which includes ensuring that there is no redundancy for your data, ensuring that your data has integrity, it has no errors, it has consistency. It also enables you to be able to maintain your data, be able to answer or get questions of any sort in relation to your data that you have stored in your database, enhance the clarity of that data, as well as reduce anomalies amongst your data. And therefore, in this presentation, we are going to learn how to do data normalization, how to apply data normalization in our structure for our database that we are going to create by the name MLSWAP School Database. For this reason, through this presentation, we are going to undertake data normalization process from scratch or from what we call unnormalized data to normalized data in that normal form, after which we are going to proceed and create our database. Therefore, in this presentation, we are going to learn how data normalization is applied to structure the MLSWAP school database efficiently by dividing data into related tables and establishing logical relationships among them. This process will follow the standard normal forms. That is from first normal form, which we initialize as 1 and F. Second normal form, which is written as 2 and F. And that normal form, D, and F to eliminate data anomalies and maintain consistency across the database. And therefore, the process of database normalization is done in 4 main stages, which we call the normal forms. So which are the 4 main stages in data normalization or database normalization? Number 1, we begin with what we call a normalized form, UNF. It is also called the zero normal form or 0NF stage. This stage simply entails putting all the data that you have gathered in one massive table with repeating groups, redundant and composite fields. In other words, in first stage, we simply begin with having all our raw data or our raw data together. And at this stage, we have a single flat table. In fact, it does not even qualify to be called a table, but just a flat file. This flat file contains all your data that you have collected, put together. And therefore, this data contains a lot of repetitions because it is not organized properly. So it just holds raw data, which you then take through the normalization process. Therefore, the first stage here, which we are calling a normalized form, is not usually a stage in normalization. In other words, the data in it is not said to be normal form. But because this is always the beginning, you cannot normalize data that is not available. We treat it as the first stage in the normalization process. It is the initial stage. The second stage, which of course is now the first normalization step, is what we call the first normal form, 1NF. This stage entails removing the repeating groups of data that is existing in the unnormalized format, thus resulting to one large table, but with flattened rows for each record with one value per cell. In other words, in the first normal form, what we simply do is to ensure that each field holds only one piece of data. For example, instead of having a field called courses, as we are going to see, holding 2 courses at the same time. For example, Introduction to Programming and Database courses, we create separate records for each course linked to the same student. Therefore, your main role in the first normal form stage is to make sure that there are no repeating groups in a single cell and each field holds only one value. Therefore, at this stage, what we do is we break down all the repeating groups of data in the same field into separate rows, but on a single table. The action taken here is that atomic values are ensured and multivalued fields split into individual rows. Then in the second normal form, which in this case, I'm calling it stage 3, what we do here is we remove partial dependencies. So partial dependencies are removed at this stage and the entities separated into their individual tables. Here, every non-key field depends on the whole primary key. It results into each entity having its own table. Therefore, at this stage, what we do, we simply break the large table into separate tables for each entity whose fields or attributes depend on the whole primary key. We are going to see what all this means in the next few seconds in this presentation. The action here is to divide the tables so that each non-key attribute depends on the whole key. Then the last step, or what we call stage 4, but it is the third stage, in the normalization process is what we call the third normal form. At this stage, all transitive dependencies are removed. All non-key fields are meant to depend only on the main primary key and not on other non-key fields. It leads to a clean relational schema with foreign key links. And therefore, at this stage, that is in the third normal form in our normalization process, what we do is that we refine our tables by removing transitive dependencies such that fields that rely on each other are retained in their normal individual table. For example, if a table has a field called student ID, department ID, and department name, the department name here depends on department ID, and therefore it does not depend on student ID. So what are we supposed to do? We simply move department details to a department table. We unlink it from, or we remove the student ID from this table. The action taken here is to remove transitive dependencies and organize data into related tables. So those are the main stages of normalization process. So let's see in depth what each of those stages entail as we do it practically in the process of coming up with a foundation for our database by the name MLSwap School. The following is therefore a detailed description of the normalization process for a database called MLSwap School for subsequent database creation using Microsoft Access. So this is an illustration on how we make use of or how we do the normalization through all the stages you have looked into. And in our case, for this demo or for this explanation, I'm going to make use of records for 2 students. But of course, as we proceed with database creation, and once we acquire the tips or once we acquire the skills on how we do the normalization, we are going to increase our number of students that we're going to be storing in our normalized tables from 2 to 7. And this is simply for demonstration purposes. Let's begin with the first step. We have said that our first step is to ensure that we have all the data that we need to normalize into tables in advance. And therefore, in step 1, we have what we call the normalized format stage, or we call this stage a normalized format stage. What does this stage entail? It simply entails establishing one big messy table with all the data for our school, composed of repeating groups, multi-valued fields, composite entries, and redundant information. So in stage 1, we put all our data together. We gather all our data together in one large messy table, or just call it one flat file, a file with all the data that we are going to require to create our database, all the data we are going to need in our database. So it looks as follows. So this is just an example. When we are gathering all our data that we are going to store in our database, once we have all that data, we can put it in such a form. So this is an example of a normalized data, and this a normalized table. When you look at this, a normalized table, I'm making use of an example of data for 2 students. We have the fields here. What I'm calling first record and second record are simply the details for each student. So we have 2 students here. This is data for 2 students. And this data is all the data that concerns the student. It is not well organized. We can see that in this table, we have a field called student ID. Now, in the database creation or in tables creation, this is not really going to be the actual, or these are not going to be the real fields. It is for the purposes of enabling you or helping you be able to see what we are calling a normalized table. And therefore, what you can see here, what I'm calling student ID, is of course a field in this case for holding the identification for the students. So these are like the animation numbers. We have S001 and S002. We have student name. And if you look, each of these names are the full names. Like Jane, Jerry. Jane can be a different person. Jerry can be a different person. We have John Mwangi. John can be a different person and Mwangi can be a different person. So you can see already that what we are calling student name is composed of two words each. Jane Jerry, John Mwangi. Then we have date of birth. And we have that date of birth and that date of birth. We have the gender, which is F for female, M for male. We have phone numbers. Remember, a single student can have more than one phone number. So we have the phone number for Jane, we have phone number for Mwangi here. Email. These are the emails for our students. We have jane@gmail.com, john@yahoo.com. We have the address. And the address for Jane is PO Box 48 Meru, and for John, it is PO Box 2.1 Nairobi. We have the department. Jane belongs to ICT. John belongs to business. Now, my dear students and the rest of the learners, the most important information or what is key in this normalized table is this field, program details table, or not table, but program details field. The courses, the payments. Now, why am I saying that this is the gist for this normalized table? It is because what we are calling program details field, it contains more than one piece of information. We have the name, we have the fees, we have the duration. For example, for Jane, under the program details, you can see in this field, we have the course that the student is taking, diploma in ICT, the amount of fee that this student is supposed to pay for this course or this diploma. And we have the duration, 2 years, all put together. For John, this student, in this field, we have the course or the diploma the student is taking, diploma in business. The total cost, 28,000, and the duration, all put together. When you look at this field called the courses, you can see this data is also cluttered here. We have the course name and the credit hours. If you look at Jane, we have Introduction to Programming as the course. The course is supposed to give or account this student 3 credit hours. We have also another course called Databases, whose credit hours are 4. So you can see under courses field, we have 2 things. We have the course, we have credit hours. So here we have 2 courses put together and their credit hours. The same applies to John. You can see John in the front for courses. John is taking 2 courses. We have accounting course, we have marketing course, and at the same time, accounting course is taking 3 credit hours, marketing 3 credit hours. Yet all this information is put together in the same field as other courses, and the same applies to Jane. The academic year is okay, term is okay, but look on payments field. This payment field contains more than 3 pieces of information. We have the payment date, when the student has made the payment. For example, 12th February 2024. The amount the student has paid, 1,000 shillings or 10,000 shillings, and then the mode or payment, M-Pesa. At the same time, on the same field, we are having the same student paying 20,000 on 15th March 2024 in cash. So this is a lot of information, my dear students and the rest of the viewers, that is clustered together, under the same field. And then we have for John, we have 28,000 being paid on 20th February 2024 through the bank. So my dear students and the rest of the learners, these are some of the areas of our concern. And that is why this file or this table is being said to be anomalized. What happens if, for example, you delete or you remove the program details from this table? By just deleting that field, the whole of it, you lose a lot of information at once. If, for example, by mistake, we remove or this field is lost or is deleted, what happens? We lose all the information concerning the payments. So a slight error in this file, remove of payments field only, will make the institution lose all that information concerning payments in the with payments. So these are some of the issues that we see in unnormalized data, unnormalized table. And that is why we have now to commence the normalization process to break down this information, separate it, put it in different tables, have it in different fields for ease of management of this data. So this anomalized data is said to be anomalized because it contains the following characteristics. Multiple values are stored in the same field, like student name, it contains the first name and second name. The program details, the courses, the payments contain multiple values. In addition, data is said to be in a normalized format. If when you make a slight change in one area, it might not be in tandem with the rest of the areas. So it causes what we call update anomalies. For example, if program fee changes, every student record must be updated. And this one has been done one at a time. Why? Because the fees issues have not been centralized to a specific table, so that when you make the change in that single table, it is reflected across. In addition, we have what we call the insertion and deletion anomalies. Deleting a student record, as I have said, deleting a single field for a student, like the one for payment, it can lead to removal of a lot of information that relates to, for example, payments. So deleting a student could remove the only record of a course or a payment. In other words, that information can disappear completely because we don't have strategies put in place to ensure that a slight mistake does not get reflected across all the database. We also have what we call lack of relational separation. Everything from personal information, the fees, the programs, and other transactions, as you have seen, is lumped into specific records or into specific fields. So these are some of the things that we need to deal with. So in this anomalized file, each student record contains personal details, contact details, academic program and department, repeating course data, repeating program data, fee and payment history as nested list. So all this information has been clustered together, and this is not good. So we have now to take our data through the normalization process. Why? So that we can be able to eliminate the repetitions So in the first normal form, as we are going to see, we are going to separate each repeating group or split the data. For example, in program details table or in program details field, the courses, the payments. So we are going to separate that data. Any data that is stored together under the same field, more than one piece of data, we are going to split it. We are going to separate it. That is in the first normal form. In the second normal form, we are going to remove partial dependencies. That is, for example, program and department redundancies. So we are going to remove the dependencies. We are going to see what that means just in this presentation. In the third normal form, we isolate each logical entity. The students, we put them separate. The student details are put separate. The program details are put separate. The courses are put separate. The departments are put separate. Payments, etc. So we organize in the third form, normal form, we ensure that that data, which is completely related and relies on each other, is put in its own table. Therefore, database normalization process always begins with a normalized data, or 0 and F, which is then taken through the normalization process from the first normal form to second normal form and to third normal form. Of course, there are other normal forms, but the highest in this case is the third normal form. Once you reach the third normal form of normalization, your data is ready for automation. You are ready to create database using a database management software. So the data in 0 normal form, which we are calling a normalized data, is said to be one big messy table or file with repeating groups, as we have seen, what we call multi-valued fields, like the three that are highlighted, composite entries, and redundant information. Let's now move on. Once you have your normalized data that you have looked at, the next step now, which is now the first stage in normalization, is to reorganize or restructure our data into what we call the first normal form. So what did we do in the first normal form? The goal of first normal form is usually to eliminate repeating groups and ensure that each field is atomic. That is, each field contains a single value. So what we do is we split multi-valued attributes into separate rows. Those fields that I've already explained about in the normalized table that contain more than one piece of information or data, we are going to split it. So we split multi-valued attributes and we make them to be separate rows. This is done by adhering to the rule of the first normal form, which is no repeating groups or multi-valued attributes should occur in a single field. Each field should contain atomic values, a single value per field. So we see that after we have normalized our table to first normal form, we have not, or we shall not have removed redundancy. What we shall have done is only one activity: to atomize our data. To atomize our data. Atomize simply meaning ensuring that each field contains only one piece of data. One piece of data. So we still have redundancy, or we may still have redundancy, but every column value is atomic. The strategy applied here is to expand the repeating groups so that each role owns one piece of data. For example, program detail, course, and one payment item at a time. This produces multiple rows per subject. In other words, when we undertake our data, or when we take our normalized data to the first normal form, what happens is that we end up with an expanded table. Why? Because when we break down, when we split a field into its respective items, we end up having what we call multiple rows. And these multiple rows, therefore, lead to additional or expansion of the table. For example, student, if they have multiple courses or payments, we split those courses. Like we have seen in the two examples I've given, that Jane has two courses, John has two courses. So when we split those courses into separate courses, when you split them, it means we shall have added an additional row. If the row was one, when the two were lumped together, and we split the two, so we end up with two rows. The same applies to payments. Therefore, when you normalize data to first normal form, you usually still have one large table. The key goal at this stage is not to split data into different tables, but it is to make the structure of that one table orderly and atomic. The following are therefore the steps that we undertake when we are normalizing our unnormalized data to one or to first normal form. Number one, we identify the repeating groups. We check our records, we check our fields to see which field contains more than one item, which are the repeating groups, which data is repeated. So from our row table, we have three repeating groups. These three repeating groups are, or where we have repetitions, is the program details. Where we have the name, we have the fees, we have the duration, all of them lumped together. So under program. So in the program, we have seen we have program name, program fees, program duration, all of them lumped together. Courses, we have seen that we have course names and credit hours put together. So that has applied to both of the students. We have also seen the payments field where we have repeating groups. We have data for payment date, amount paid, and payment mode, all of them lumped together as each student. So once we have done that, then step two on that process is to flatten that data. So to flatten that data simply means that we ensure we split each of them so that each field owns a single value. We create a first normal form table by expanding the repeating groups so that each combination of fields becomes a separate row. So every cell now holds just one value. No enclosing in braces, in parentheses, no use of commas, no use of sets. So we just ensure that each data stands on its own. Once we have done that, we write out the first normal form table. Therefore, our first normal form table will look as follows. Here it is. My dear students and the rest of the learners, I want you to note that this table has expanded. If you look at this table in our first normal form, and then we go back and look at the table which was normalized, I want you to see it. If you look at this normalized table or normalized file, which contains all the data, you will see that the number of rows and the columns here, the number of rows and the columns here are a few. Look at them. The number of fields are also few. But when we normalize to the first normal form, I want to go there, you will see that that information has almost like doubled. It has expanded. It has expanded. And one thing I want you to note, my dear students and the rest of the learners, concerning my method of demonstration for this table, in a real sense, these fields would not be on this side, but they would be on this side. So that then this data would be moving this way in form of rows. So when I speak about rows, In this case, it's good for you to note, I'm not talking about the data this way. This is purely for fitting on my screen. When I refer to a row, or to a record in this table of mine, I'm referring to this information this way. These are the rows. I know you may wonder why I'm calling them rows and this is not how the rows are supposed to look like. You can easily call these columns. But when you look at it carefully, you'll see that I've written my information downwards. This is purely for the sake of fitting on the screen. So these ones would be the headings. These would be the headings. They would be the column headers. While these are the rows. So I have clarified that so that you are able to understand that I'm simply having my data presented in this manner so that it fits on the screen. And therefore, after splitting our fields, what has happened? So what have we split in the first step or in the first place? Let's look at this table in the first normal form. The student ID has not been split. The content has not been split, but you can see it has, each of them has been repeated. We are going to see why in the next few minutes or seconds. The student name remains Jane Jerry, Johnny Mwangi, Johnny Mwangi. Now, what comes out very clearly from the beginning is that it is as if for each student, we have increased the number of records. So we have first record and second record for the same student, first record and second record for the other student. We shall see why. It's as a result of the splitting of the composite fields or splitting the data which was put together in the same field. The date of birth, yes, we have phone numbers. Each, of course, has a single phone number. There has been no splitting. Remember, the overall task when you are developing a table in the first normal form is simply to split the data which has been collected together or put together or collated together into separate fields. Splitting, that's the key. Email has not been split. Address has not been split. The department name has not been split. Now look at this. This is the data which was put together. This data had been lumped together in their normalized table that we have already looked at. But now, in the first normal form, we have split that information. So the program name has been made standalone. So the program name for Jerry is Diploma in ICT, and for Mwangi is Diploma in Business. So we have put the program separate. We have also put program fee separate. So the program fee for Diploma in ICT is at 2,000. And also it is 20,000 for business. So we have separated the program name from the program fees so that they are put as separated records, not records, but fields. We have also put duration separate, 2 years, 2 years. So that is one area that we have affected in first normal form. Let's also look at this other one, the course for the courses. You see, here now, we have the course name separate and credit hours separate. They were lumped together in their normalized form. So under course name, we have enhanced programming and the credit hours is 3. Now, the same student, and that is why now this is another record. The same student is taking another course called database, whose credit hours are 4. So in a real sense, this is one of the areas that has made us duplicate the student, Jane Jerry, to become 2 records, such that in one record, we have interactive programming, and in the other record, we have databases. So this is where we have a change from what we had before. So because of the fact that the same student is taking more than one course, and you cannot put the two courses under the same field, that is where we have split the details for each of the students into two, so that the first record for the students owns the first course and the credit hours for that course. Together, of course, with this other information that we have also split. You can see Jane is also having 2 modes of payment, M-Pesa and cash. And the amount paid is different. And also the payment date is different. So we have also done the same. John had also 2 courses. The first course being accounting 1 and the second one being marketing. So we have also split the courses into 2, and as a result, each course is having its own record, or for each, we have complete record for a specific student. So John Mwangi now is having 2 records, and Jane Jerry is also having 2 records with a lot of information being similar. So when we look at the academic year is 2024. Now, the term, that one has not changed. But as I've said, we have also split the payment into 3 additional films. The payment date, separate. The amount paid, separate. And payment mode, separate. And therefore, if you look carefully, the whole of that record and this record belong to the same student. But what are the changes? The changes are occurring where you find that the same student had information which was kept together for 2 different things, like for programming course and databases course, and for mode of payment or for the payment also. So it is as a result of the fact that Jen was having more than 1 course and more than 1 mode of payment that has made us split these 2 records to behave as if they are 2 different students. John Mwangi was also taking 2 courses, accounting 1 and marketing. So as a result of that, we had also to split the record for Mwangi so that it becomes 2 records, complete record, the first record and the second record. So my dear students and the rest of the learners, as you can see, when we are normalizing our table to the first normal form, you find there's a lot of repetitions, as you can see, and our table has expanded. Our table has expanded, and there's a lot of redundant information. There's a lot of duplication or repetition of the same information from one record to the other. So once we have done that, it's always good to verify that our table that we've come up with is in first normal form. So how do you verify? You ensure that, number 1, each cell has a single value. Is each cell having a single value? Yes. What am I calling cells? What I'm calling cells are these. These are the example of a cell. These are the cells. So you ensure that each cell, or call them fields, you ensure that each field has only is 1 piece of information. Of course, I know when you look at the address, you may think that these are different types of data. No, you cannot remove the place from the box. So address is complete when it is this way. So that's why we are not splitting address. It is called an address because of what it contains, the content. So you don't split what is not supposed to be split. So as you can see, each field or each cell is having same or 1 piece of data. We don't have any cell having more than one piece of data at the same time. So we have removed that. So that's one indication that this table is in first normal form. What is the second thing you need to check is to ensure that there are no repeating groups or arrays. When I talk about repeating groups, I'm not talking about duplicating the record. I'm talking about having, for example, a field, like for example, a course name being repeated somewhere else or having repetitions of the same thing. Like, for example, you could not say because these are two courses that you are going to, instead of having two records separate, like the way we have them, you could not say that you merge them or you put them as specific fields. So you would not, for example, say this is course one or course name one, introduction to programming, and then you have course name two below here, and then you write databases. And then credit hours, you have credit hours for course one and the credit hours for course two, all of them being listed as separate fields. By doing that, you'll be repeating the same things. So that is why the best thing is what we have done to duplicate the records so that we don't have repetitions for any fields. We don't have any field having more than one piece of data, but we have each separately. So you ensure there are long groups or arrays. Then you also ensure that every row is unique. You could define a composite key. What I mean is unique. I'm saying that every row should have something different from the other row. What I mean is this. If you check for each student here, we have certain rows. Like S001, Jane Jerry, is having this row and is also having another row, or call them records. But they are not the same 100%. There is a difference, and the difference is here. You can see we have this difference. Even this and this is different. This and this is different. So that's what we are saying. For Johnny Mwangi, this, not that, but this part and this. So this record, first record and second records are not 100% similar. You can see there's something different. So the main difference, as you have seen, is at this point. So you ensure that in first normal form, you ensure that the table which you have created for each row, there is something unique. And then once we confirm that each cell has a single value, as you have seen, there are no repeating groups or arrays, every row is unique, we can therefore confirm that we have our first table, or we have our table in the first normal form. However, as you have seen, we still have lots of redundancy. Students' information repeats for each course, as you have seen. Now, that is okay for first normal form table, because that is what we are going to reduce or to deal with in our second normal form. We are going to remove redundancies. Therefore, the transition from a normalized form to first normal form is breaking composite or multi-value difference into atomic values, therefore ending up with repeating data, or what we call redundancy, by expanding records or rows. Very important. In addition, we combine different entities, e.g., students with the program's data in the same table, and therefore that means to be structured further. I'm saying if you check in the table which we have looked at, we have a lot of information, all the information about each of the students. It is put together in the same table, but we have now to do some separation, and that is what we are going to deal with in our next level or next stage. So we need to proceed to the next normalization level to deal with the dependency problem. And therefore, let's look at what we do in our next stage. Call it step 3, but it is stage 2 in normalization. We call it second normal form stage. The overall goal for this step is to remove partial dependencies. That is, attributes that depend on a part of a composite primary key should be moved in separate tables. In other words, every non-key attribute must depend on the whole primary key. Usually, a table in second normal form is already in first normal form, and every non-key attribute is fully dependent on the entire primary key, not just part of it. In other words, my dear students and the rest of the learners, what is it that we do in second normal form? Number 1, we are going to reorganize those fields we have looked at. We are going to reorganize them based on their relatedness, based on their closeness. We are going to organize them, and we split now our large table into separate tables into separate tables. So second normal form step. In this step, we have a key outstanding characteristic or behavior of splitting the large table into separate tables. Since our first normal tables key will be something composite like student ID, course name, payment date, there is a lot of partial dependency. For example, the student name depends only on student ID, not on the course or payment. So why should we have all of them together? We have to remove. We have to separate them. Therefore, at this step, we split our table from first normal form into several tables. Based on what? Based on dependencies and with each table focusing on one entity. So it is done as follows. Number one, you identify the entities. You look at all the fields that you have, and then you ask yourself, from all these fields that you have, which tables can you come up with? Which tables? Therefore, when we look at our first normal form table that we have developed so far, if you look at this first normal form table, this one that we have already looked at, when we look at this first normal form table, there are fields that seem to match together, but they can be separate. Like the student ID, student name, date of birth, gender, phone number, email, and address. Those are student details. They can be put separate. Those can form their own table. So that's a table, student details. When you look at department name, that can be put separate. The department can be separate. When you look at the program, for example, diploma in ICT, the amount of fees you pay for that program and the duration, those can be put separate. The course is here. The course name, the credit hours, the academic year, and the term, they can be put separate. Look at the payments. The payment date, amount paid, and the payment mode. We can have that information put separately on the payments. That's what we are saying, my dear students and the rest of the learners, that we don't need to have all this information put together, yet we can be able to separate it. And therefore, in our second normal form, what we need to do is to identify those fields that can be put separately. And therefore, we identify the entity. We ask ourselves, which tables can we come up with? And therefore, it is natural, as you have seen, that from our first normal form table, the following can be the fields or the tables that we can come up with. Students table to contain core details about each student. The departments, the information about the departments can be put separate. Department like ICT, business. Then programs. Each program belongs to a department. So each program or details about the program can have its own table. The details or information about the courses can be put separate. And of course, they belong to programs. So there should be some connection. Then enrollments. We can have a table for enrollments, which shows which students takes which course and the year as well as the term. Then we can have students payment per term, per year. So we can have details about payments put separately. So my dear students and the rest of the learners, I want you to note this, that when you are normalizing your tables to second normal form, one of the main things you need to ensure is that you come up with a table. You break down that large table in the first normal form to smaller tables based on the fields that you have. Good. So that's the first step there. The second step now is to create the second normal form tables. So our large table will not be structured into several tables by each entity as we have seen. So here we go. We have our students table. So what will our students table contain? It will have the following data: first name, last name, date of birth, gender, phone, email, and address. Those are the natural ones that we have picked, as well as student ID. But there's also something that you should note here. Because every student is taking a certain program, that is why we have introduced a field here called program ID for the purposes of helping us be able to know which student is taking which program. So as you come up with your tables, it is important to ensure that each table contains some field. It contains a certain field which can enable you to be able to see the link between that field or that table and information in another table. So that's why we have a field called program ID for our students table, which is the other table and what information we need to have in it. The second table is departments. Now look at this new table. This table called departments, as you can see, it has two fields. One of the fields was not there in the first normal form table. Now this field is the department ID. So we introduce, in each table, we introduce a unique field. We introduce a unique field for identification purposes so that we don't repeat the same information in other tables where that information may be required. So that unique field is what we call a primary key. So we always have a unique key for each table. As we group our fields to specific tables, we ensure that each table has a unique field for identification purposes. So we have two fields for departments table. We have the department name and we have department ID. So the department ID will be used to identify the department. So anywhere where we are going to refer ICT department based database that we're going to create, we are going to be using D001, business D002. For the programs, we are going to see what P001 and P002 is from the programs table. So, my dear students and the rest of the learners, kindly note that when you are normalizing our tables to second normal form, other than classifying or reclassifying the fields that are written together, we also add a field, one, to help uniquely identify that table or those records in those tables. And number two, we also add a field which can act as a linking field to connect to another information in another table. Very important. So our third table is called programs table. You can see we have also introduced a unique field here called program ID, which was not there. And then we have the program name, the program fee, and duration. And as I have said, you can see we have introduced another field here. So we have program ID, which we have introduced for identifying each record uniquely. And now you can see P001 is an ID, identity for diploma in ICT. P002 stands for diploma in business. So anywhere we are going to use P001 or P002. P001 will be defined to diploma in ICT. P002, diploma in business. And for the purposes of showing that a program is being offered through a department, that is why we have this field we have added here called department ID. Note this. Program ID, primary key for identifying each record uniquely. Then we have added another field for the purposes of linking, showing that this data in this table, this data has a relationship with another information in another table. So programs are being offered through a department. So we have to indicate diploma in ICT is being offered through which department? D001. That is, as you have seen, ICT. Diploma in business is being offered through which department? So, my dear students and the rest of the learners, as you develop tables in second normal form, kindly note those aspects. Primary key and a key or a field, which is going to be used for the linking. In fact, we call this other field a foreign key. Foreign key. Program ID, primary key. Department ID, foreign key. Let me also show you in this other table. Students table, student ID, primary key. Program ID, foreign key for a different one. Anyway, I'm going to explain further. I may confuse you when I talk about foreign key and the primary key. A foreign key in one table is a primary key in another. That's what I'm simply saying, but we are going to see more as we proceed. The courses table. Our courses table is composed of course name, credit hours, and program ID. And we have introduced course ID as the primary key. And to show that these courses belong to a certain program, they belong to a certain program, you can see we have added program ID. So course name and credit hours are directly from our first normal form table. But in the second normal form, we have introduced two felons. Felon for identifying every record uniquely, called course ID is a primary key. And we have the program ID for the linking purposes. And remember, the program ID is the primary key for the programs table. Note that and let it sink in your nerves. Then we move on to the next set of tables. We have the enrollment table. Same case applies. We have introduced a new field called enrollment ID, which serves as the primary key to identify each record for each student who has been enrolled. And we have also the student ID to show who is 001 belongs to. And then we have the course ID to show which course each student has been enrolled into. You can see. And the course ID is a primary key in another table. Student ID is also a primary key in another table. But our primary key here is less. So these other two are not primary keys. You can call them foreign keys. In the payments table, we have introduced the payment ID as the primary key. And then, of course, we have show who has paid. We have the student ID. Of course, we know student ID is a primary key somewhere else. And the rest of the information is as you can see. And therefore, my dear students, it's very important for you to note how we come up with the fellows in second normal form. So once you have come up with the tables, before you move to the next step, you ensure that each table has a single primary key, as you have seen. All non-key attributes depend entirely on that key, non-partial dependencies. You have seen those fellows which I'm saying that they are primary keys and other tables. But in the cases where they have been added or where they have been included, they are not the primary keys. And then we also ensure that we have removed repeating groups. We have eliminated. So in our case, we now have achieved second normal form tables. Therefore, the transition from first normal form to second normal form entails the removal of partial dependencies by moving attributes that belong to different entities into separate tables. For example, we now have students table, departments table, programs table, courses table, enrollments table, and the payments table, all from a single table. And the last one, the last step, is to take our normalization level to what we call that normal form. And that is the fourth step. The goal for that normal level normalization is to remove transitive dependencies. That is, non-key attributes that are there must not depend on any other non-key attributes. Well, the rule to adhere to is remove transitive dependencies. That's what we do in that level, that normal form level. That is, non-key fields should not depend on other non-key fields. We thus check for transitive dependencies and finalize the table layout. The non-key attributes must depend directly on the primary key, not by another non-key attribute. Therefore, at this point, what do we do? We remove transitive dependencies and link tables with keys. Each table is assigned its primary key. Of course, we have seen that also from the second normal form. So what are some of the common transitive problems? For example, in our case here, we have the program name and we have department name. So if program owns department name rather than department ID, that is transitive. So we have to remove that. Fee amount. If fee amount is derived from program, then you have to show it, or from there by having it in the right place. So in our design fee is per student per program or term. And it's for that reason that we have ensured that fee amount is treated as an attribute of program so that we don't store it in the student's details table. So you have to ensure that specific fields are in their respective tables. Therefore, the actions to reach that normal form are as follows. Number one, you ensure that each table's non-key attributes depend only on that table's primary key. Number two, you use ID to link related entities rather than storing their descriptive fields. So we make use of keys. By this stage, that normal form, the database becomes lean, elegant, and logically airtight because it is already free from repeating groups that is as it was in the first normal form, and the partial dependencies as it was in second normal form. So we now take away what we call the transitive dependencies. That is, when a non-key field depends on another non-key field instead of directly depending on the primary key. Therefore, our final Vant normal form tables as it would appear in Microsoft Access datasheet view will be as follows. And these are the ones we are going to use to create our database commencing from our next presentation, which is the 7th part in the series, henceforth. They are the ones that we shall use. And therefore, this is how they are going to look like for the students table. Now this table, you can see there's a similarity. There's a very close similarity between tables in second normal form and the tables in that normal form. As you can see from this table, there's nothing new that we have introduced which was not in the second normal form table. We have only added the key for the primary key here. So that is how our table look like. It has the primary key, and it also has this key, which you have added for the purposes of being able to show which program each of our students is pursuing. But note, we use the acronym, the key. Program ID, that is the program key. We don't write the name of the program there. Then our second table, departments, will be like that. It has the primary key called department ID. And of course, the department name. You can see very simple and lean tables. The programs table has the program ID for identifying the program, and we have the details of each of the programs. And of course, we have the department ID there for the purposes of showing that each program belongs to a certain department. We have the courses table. The courses table has primary key, course ID, and it has the rest of the information, but we have the program ID there to show that each course belongs to a certain program. Look at that. You don't just leave a table pending. You have to put a field connected to another one. Then enrollments table. We have enrollments ID as the primary key. And of course, we also have the student ID to show who has been enrolled to, which student has been enrolled. And we have course ID to show which course has the student been enrolled into. So the enrollments table is purely showing the students who have been enrolled in our institution and the courses they have been enrolled to pursue. Lastly, we have the payments table. It has the payment ID as the primary key. And of course, we have the student ID to show who has paid what. So to get the details, we go to the student table where we have the student ID to find out who S001 stands for. And as you can see, a single student code or whose ID is CS001 has made 2 payments. So payment ID is like the receipt number. Then student ID is the person, the identity of the person. And then we have the rest of the information as you can see. So those will be our tables. Therefore, our tables are now in that normal form, ready for creating the database because, number one, no transitive dependencies exist. All non-key fields depend directly on the primary key. Each entity describes one concept: students, departments, programs, etc. There's no picture. If it's a table about the students, it's the students. If it's about program, it's the program. And if we have to show a link of that information to another table, we only introduce a field which contains the identity. That is an ID. Data redundancy is minimized, or referential integrity is maintained, as you have seen. Therefore, the transition from second normal form to that normal form entails the elimination of transitive dependencies by ensuring attributes depend only on the table's primary key. That is, use ID keys like department ID instead of storing department name in programs etc. as we have seen. So once you have done that, you can see that is the end of the normalization process. And as you carry out that activity, you notice that for the second normal form tables and the third normal form, we have to establish primary keys. And you have to think about how one table is related to another, how our database will be related. So this is just a summary. As you have noted, the process of establishing the primary keys for the tables, as well as determining the relationship between the various database entities, are a part and a parcel of the normalization process, and especially at the last level, which is ranked normal form. Therefore, our final normalized swap school database that we shall create will be composed of the following 6 tables, composed of the following indicated fields. We are going to see that we are going to have a table called the students. It will have those 6 fields. Student ID as the primary key. The others will be there, and to show the link between students and programs that the students are taking, we shall have program ID there. Departments, we have department ID and department name. Department ID as the primary key. Programs, that table will have program ID, program name, and the rest, as you can see, and we have department ID there for the purposes of showing that each program belongs to a certain department. Courses table, we have the course ID, which will act as the primary key for identifying each course. And at the end there, we see we have program ID to show that the course belongs to a certain program. Details can be found in the programs table. Enrollments table, we have enrollment ID, primary key. The others are there. And the student ID, of course, is there to show who has been enrolled to each course. Payments table, we have the payment ID, the rest information of the information is there, and we have student ID to show who has done the payment. And therefore, these are the 6 tables that we are going to have. And these tables will therefore be composed of the following primary keys. So you can see coming up with the primary keys is part of the normalization process. You have to know which field will be primary key. And you have seen you introduce primary keys. You introduce those fields to a table if they don't exist already. You introduce them. So the students table will have the primary key, student ID. Departments table will have department ID. Programs table, program ID. Courses or course ID. Enrollments table will have enrollment ID. Payments table will have the payment ID. And we have seen this very clearly and why it is important. These tables will then be linked or related through their primary keys and their foreign keys. So you link them by dragging the primary key field to its respective foreign key and releasing through the relationship window. When a prompt message appears during the linking process, that is creating relationships, make sure you tick enforce referential integrity and choose cascade update related fields checkboxes. We are going to see that in our next subsequent presentations. So you will link them as follows by dragging the primary key field from its table and dropping it on its respective foreign key in the other table. Now, I want you to look at this. We have said in the department table, we have a field called department ID. We have also seen in the programs table, we have a field called department ID. So when you are linking the two, you drag and drop that, and you shall be doing this practically. Programs table, you link it to students table through programs ID. You can see the importance of including those fields that we are discussing about. Those which show which other table contains what information, the link. You can see the program's ID fields will be linked to courses program ID. So you can see student ID in students, students ID in enrollments, course ID in courses, course ID in enrollments, students ID, student ID in students, student ID payments. Those are the ones that you link. So student ID in this table is primary key, but in this other table, it is foreign key. Course ID is primary key in courses table, but it is a foreign key in courses table. And the same applies to the others. Department ID is primary key in departments table, but it is a foreign key in programs table. So you link foreign key or primary keys to their respective foreign keys. That is after you have already established your tables. And therefore, you finally map up entities and relationships on paper or with using a tool. You draw the entities, attributes, relationships. Therefore, it is vital to draw the database's ERD before you proceed to create the database using database management software, such as Microsoft Access. So the following is our MediSwap entity relationship diagram. This is where you end the normalization process. This is the peak. This is the peak of designing your database. Designing your database completely. Because from here, once you have been able to develop this ERD diagram, you can now proceed to computerizing your system, to using your database management software to create your database, to create your tables, create the relationships, etc. Now, this is like a roadmap. It is important. It is vital. This is our entity relationship diagram for creating a MediSwap school database. This ERB is showing the following. We have all the tables in our database: students table, payments table, enrollments table, programs table, courses table, departments table. It is also showing the fields in each of the tables. In the students table, these are the fields. For the payments table, these are the fields. For enrollments table, those are the fields there. The programs table, those are the fields. Courses, those are the fields. And departments, those are the fields. And when you look at each of those fields, you can also tell which is the primary key, which is the foreign key. So in the students table, you can see we have student ID. And in the payments table, the student ID is there. It is a foreign key. And it is also a foreign key in enrollments table. When you look at the payments table, we have the payment ID as the primary key. Is there. Payment ID. When you look at the enrollments, you have enrollment ID as the primary key. Programs, program ID as the primary key. Courses, course ID as the primary key. Department ID as the primary key for departments. Once you have identified all that, you now create relationships by dragging and dropping. You have to show how the relationships are. And even when you are creating these tables using database management software, after you have designed your table, you have set the primary key. Before that becomes a database, you must establish relationships. You must link the tables. They must be linked. There is no table which can exist on its own. As you can see in this diagram, all our tables are linked to one another. Each is linked to another one. Once they are linked this way, it becomes a database. All these tables hold information that are important for each and every other table. None which can do without the other in this case. So we link them, we establish a relationship. So students table is linked to the payments through student ID. It is also linked to enrollments table through the student ID. Then the students table, it is linked to, or let me say programs table, is linked to the students table through program ID. Look at that. Then the programs table is linked to courses table through the program ID, as you can see. The departments table is linked to the programs table through the department ID. The enrollments table is linked to the courses through courses ID, as you can see. So this diagram is very important. It is a very clear summary of our database that we are going to create. And remember, you do all what I've explained in this presentation before you start creating the database itself using a database management software. And with that, my dear students and the rest of the learners, we have come to the end of this very important presentation on database implementation and more so database on data normalization. You can now continue to part 7 of 22, in which now we are going to commence learning on how to create a database now using database management software. Congratulations, my dear students and the rest of the learners, for learning part 6 of 22 on implementation of database design through normalization. You can access the rest of the parts in the series, as well as other computer or ICT videos by clicking or tapping on MLSwap ICT YouTube channel below this video. To subscribe to the channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write to us through the email emilyswap@gmail.com. And remember, if you want to interact with the producer one-on-one, you have questions you would like to be answered, you would like to be taken through individualized lesson, you can join this channel and a higher level of subscription as a special subscriber by tapping on join link that is posted below this video, and then follow the prompts which are there. And once you complete the process, you'll be at a higher level of engaging with the teacher, the trainer, who is none other than MemJM or MLSwap. Thank you very much. Let's meet in part 7 of the series, and God bless.